sketch a function of this form. This is amplitude. This changes the period. This is a phase shift. And this is a vertical shift. So let me put this equation into this form. Y, we should know by now, is f of x. Amplitude here is 4. Note that I'm going to put this is C. It's in the front here, but I can move it over there. It's addition, it's commutative. The function is the sine function. B, it would be here or here. Sometimes it's outside these parentheses, but that's 1 anyway, so it doesn't matter. Now this has to be in this form, x minus the phase shift. This is x plus 4, which is x minus negative pi over 4. And negative 3 is my phase shift. So, I could see that this is 1. The period would be, for the sine function, it's 2 pi over b. In this case, b is 1, so it's just 2 pi. So it's going to take 2 pi radians for this graph, as you can see, to make one complete cycle. The amplitude is 4, and we know the amplitude is the maximum, half the difference between the maximum and the minimum. So 4 minus negative 4 is 8 divided by 2 is 4. That's my amplitude. And this will be like this pi, negative pi, and there's 0. This is actually the y-axis when x is 0. Pi on this side and pi on this side makes 2 pi. This is pi over 2, negative pi over 2. And I'll put tick marks at pi over, multiples of pi over 4, so that it'll be easier to see when we have to shift this. And let me draw a little unit circle for us to remind ourselves where the angles are. There's negative pi over 2. There's positive pi over 2. And this is, it's negative pi, but it's also positive pi. And this reflects that we're going from negative pi to pi, which means we're traveling this way. We're starting and ending at the same point, but we're going in the positive direction. So let's consider for a moment just sine of x. We'll figure that out, then we'll shift it, and then we'll apply the amplitude. So, let's start with about negative pi over 2. Negative pi over 2, this is the point 0, negative 1. And the sine we know is the y value on the Cartesian coordinate system of this point. So the sine of negative pi over 2 is negative 1. So it would be negative 1. But we have to shift it to the left by pi over 4. And then we have to apply this amplitude, which is 4. Negative 1 times 4 would be negative 4. Just don't forget the amplitude, the absolute value of A. It should be straight. Okay, so there's one point. And I have not taken this into consideration. I'm only working with this part of the graph right now. And I'll shift the whole thing down by -3. So now let's move on to 0. So when x is 0 or theta is 0, this is the point 1, 0. The sine of 0 is 0, but we have to shift to the left, pi over 4, multiply it by the amplitude, but the amplitude times 0 is still 0. Move to pi over 2, and this is the point 0, positive 1, so the sine here is 1. So it would be here, except we have to shift it to the left, pi over 4, and then apply the amplitude. 1 times 4 is 4. And then move to pi. This is the point. Put on the inside here. This is -1, 0. The sine of pi is 0. Shift it over, pi over 4. Apply the amplitude. It's still 0. So we have a graph that looks like this. I'm just dotting it now because we're not really done with the graph. Now at this point, now I'm going to apply the shift, the vertical shift of -3. I'll just do that by 1, 2, 3. It's roughly 1, 2, 3, 1, 2, 3. 1, 2, 3. So that's, and actually I'm pretty confident this is it, so I'm just going to make it a solid line. Now it's a crude drawing, but it's okay. Gets the point across. So we have this bump going up over the x-axis. This one doesn't breach the x-axis at all, so it's not this one. This one does breach the x-axis, but it's before the y-axis, which is here, and ours is after, so I'm going to rule that one out. Could be this, could be this. Let's take a test point. This is the point pi over 4, 1. And horizontally we've gone to pi over 4 and up 1. Actually we've come down 3 from 4, but that is that point. So let's see, this is split into 4, so there's pi over 4. Move up to 1, there's nothing there. This one, go to pi over 4, move up 1, there it is. So yes, we can confirm that that is the correct graph. And there you have it.